Today we are going to see how we can add two signals. So before going to that, last class I have given you one homework sum, right? So that thing we have to discuss. So first and foremost, how this can be solved is that I'm taking that color. So we have to separate this into our order. So sequential order I have let you know, right? So like this way we have to split it. So if we split this one, how this will be changing is that. So let me write here. So how that will change is that first we need to have the t value, independent variable divided by 3 plus 1 by 3. Okay, so this is how it will be looking. So here first we have to shift by 1 by 3 and we have to scale by 2 by 3 and then we have to reverse it. Okay, so this is what the order. So I think many of you guys were able to achieve this one. So even if you guys are not able to, no problem, please watch this lecture so that you guys will be getting to know about the things. Okay, so let's today solve how we can do the things is. So first we have to shift this with the positive, right? So we have to shift this leftwards. So now we have to subtract everywhere with the minus 1 by 3. So here we have to subtract by 1 by 3. So here 1 by 3. So everywhere we have to subtract by 1 by 3. So here minus 1 by 3. Here minus 1 by 3. Okay. So if we done this, so what will be the resulting values will be? So this will be minus 7 by 3 and this will be minus 5 by 4. Like that way it will come. So let me complete that one. So let me take that thing. So if I plot the signal, it will be like this way. Everything will be same as it is, no change in the values, but the time axis values only will be getting changed. So it will trace this way and it will come here and it will come and up like this. Okay, so what are these values will be? So this value will be 7 by 3 minus 7 by 3. So this is t. So this value will be minus 7 by 3. Okay, then this value will be minus 5 by 6. I think this value will be minus 5 by 6. Yes. Minus 5 by 6. So this will be 0. So 1 minus 1 by 3, this will be 2 by 3. Then here this value will be 13 by 6. Then this value will be 11 by 3. Okay, 11 by 3. So now what we have done is that we have shifted the signal. So this is x of t plus 1 by 3. If you 3 the positive, so we have shifted this slightly to this one, means left side it got shifted. Okay, now what we have to do is that we have to scale this by 2 by 3. Now what we have to do, we have to divide the entire x-axis value with 2 by 3. So now we have to divide by 2 by 3. Here we have to divide by 2 by 3. So everywhere we have to divide by 2 by 3. Okay, so that's like this way we have to do. Okay, so if we divide by 2 by 3, what will be the resulting value is that, let me write it in a green color. So what will be the thing is that this will become minus 7 by 2 because 3 will get cancelled, and this value will be minus 5 by 4. Okay, then this value is 1. Okay, so this will be 1. Then this will be 13 by 4. Then this will be 11 by 2. Okay, so this will be the changed value. So the green color marked values are now get changed. The x-axis value won't change. The plus 1 minus 1, the sorry, y-axis value won't change. That will be as it is. So now what we have done here is that, so in this green color what we have done is that we have scaled this with the 2 by 3. 2 by 3 t plus 1 by 3. Okay, now only one more thing is pending. That what is the thing is that we need to reverse it. So time shifting, right? So that's not time shifting, that reversal, time reversal that you have to do. Okay, so let me do it here itself. So let me taking the green yellow color for this one. So this is the time axis. So now what I have to do is that we have to reverse the signal. So this thing will come that side and that will come here. So if we trace this one, so at the minus 1 this will come like this, then it will go over it and it will be tracing like this, exact mirror image. So we should not do any mistake here. The exact mirror image you have to do it. Okay, so this is how it will be looking. So if we write the values here, then this will be t and this is our y of t. So how the y of t values will be there is that this value, this will start from 1 here and this will go over minus, this is minus 1. So this will be minus 13 by 4 and this will be minus 11 by 2 and this will be positive 5 by 6 and this will be 7 by 2. So this is 5 by 4, right? Yeah, 5 by 4, 7 by 2. So this will be positive. So this will be plus 1, this will be minus 2. Okay, so I think you're able to understand this, right? So the normal signal which is given, so here we have shifted and then we have scaled, and then we have reversed. So this is how the normal process that we have to follow. I think plenty of guys were able to solve this in the homework itself. So if you guys haven't do that, so please follow this one. So this is what the exact order we have to follow. So you may ask the question, why can't we first reverse and then adding? So please do that also, and you guys will change. You guys will see the difference over it. So let me give you one example there. So if we substitute, if we get the value of x is equal to 1 here, so x of 1 which is equal to, here what is the value? Value will be 1. So here if we substitute x of value, x is equal to 1, t is equal to 1, what will happen? 2 by 3 plus 1 by 3. The x value which is equal to minus 1 by 3. Sorry, x of minus 1 by 3. What is the x of minus 1 by 3 here? The minus 1 by 3 will be minus 0.33. Here it will be coming, right? So this will be 0. So after shifting, this will be getting changed. But if you done any operation mistakenly, then that value will not be resembling as it is. So you guys may see the difference between over that. So that should not be expected. Okay. So here if we substitute x is equal to 1, here directly it will be 1, so 1 value, but here if you see the x is equal to minus 1 by 3, that time value that will. So after the shifting operation, the values will be getting changed. That will not be same as like the original signal or original graph. So that is what this order of phenomenon only we have to follow. This is the mathematical procedure to find out the mixed operation in the independent variable. So please careful guys while solving this one, so that you guys will be able to understand or able to get the correct way of the representation. I hope you are good with the operations over the independent variable. So now we are going to start our thing on the next thing. So now independent variable operation is done. So now what we are going to discuss is the addition of two signal. So they are given two signals. One is x1 of t over the graph of t1 t, x2 of t over the graph t. So two signals we have. Now what we have to do is that we have to add the two signals. So the plotting result is y of t which is equal to x1 of t plus x2 of t. So we have to add two signals. Okay. So even maybe subtraction, anything. x1 of t minus x2 of t. Anything that may be depending on the question that I have asked. Okay. So the addition is not that much difficult. There is some rules to track. So let me go over the rules so that you guys can able to understand the things. So rule 1. So rule 1 is that track x1 of t and x2 of t and signal it. So okay. Now we have to find out the slopes and values. Slopes and values. Slopes you guys know, right? So if there is some steep changes, that will be called as a slope. So this will be slope. If there is straight value, that will be considered as a values. So if slope is there, we have to find out the value of slope. If the value is there, we have to find out the value as a, like a or anything. So slope is m1, any kind of things we have to track it. So we have to track this for both the thing. So x1 and x2 we have to track it. So rule 2. So this is rule 1. We have to track the entire signal. This value need to be done for entire signal. Entire signal tracking. Okay. This not be much difficult. I will be solving the problem though, so that time you will be able to understand it. Rule 2. While tracking from minus infinity to infinity, never leave a previous position of addition. Okay. So we have to hold the previous position. So hold the previous position. I will explain while solving the problem. Hold the previous position. Hold the previous position. Okay, I will explain it. So don't worry. So rule 3 is that so addition of 2 point. So if there is a 2 points which is coming like this way. So for an example, if one point is pointing like above and another point is pointing below, like let me explain it. So one is going up, one is going below. So like this way, at the point two signals are interacting like this, then the resultant will be something like this way. So for an example, this value is 1, this value is 2. Then the net change will be at below. So below 1. So we have to subtract both the net change. So that is how the things will look like. So this is the rule 3. So this is addition at point. Addition at point. Okay, so cool, right? So up to this it will be very easy. So fourth rule, I think this will be the last rule. So rule 4, addition in an interval. Last we see about the addition at a point. Now addition at interval. Okay, so if we are having two signals, first example is that, so if you are having two signals, this is A signal and this is B signal, then the resultant signal, how it will look like is that, let me write it, let me write the values. So this value which is equal to A, and this value which is equal to minus B. So something, 2 point. So this is at t is equal to A, and this is at t is equal to B. Okay, so both are at the same point. Okay, so then the resultant signal, how it will be there is that, the resultant signal will act in this the same position, A to B, means here it will be A, here it will be B, but this value will be changed. The value will be there, the summation of 2 A minus B. Okay, so this is how it will be changed. So 2, here there is a two values, here there is a slope and a value. So if it is coming like this, so signal A has a slope and signal 2 has a value, then here how it is, value means it is a straight line, slope means it is changing upward. That is what the difference I am trying to say. So here A, here B, because I am saying this for interval. So here the value is K and here the slope is S. So then the resultant signal, how it will be there is that, so it will be slope, it will be slope, but the, if you see the transition, previously it was at the point M, it was at point N. Okay, so here now what will happen is that this value will be changed to M plus K, this value will be changed to M plus K, this K, the value will be added to both the integer, and the slope will remain as it is. Yes, so this is at A, so this is at B. Okay, so this is how when we add a slope and a value, it will be getting changed. I hope you guys getting it. So the third one is both are slope. So if both the signal has the slope, then how would this will be changed there? Just a simple addition of slope. Okay, so that's it. So here it is A and here it is B. This is S1, or it will be taken as S1. Here it is taken as S2. Then the resultant signal slope will be just the addition of both the slopes. The values will be as it is, so remains as it is. So here will be S1 plus S2. So both the slopes will be added together. So that's it, guys. So if you guys know these rules, then we can clearly solve any problems. So let me take one example so that we guys can crack the addition of two signals. Addition of two signals is very important, guys. In Fourier series, Fourier transform, everywhere we'll be doing this one. So please listen carefully. So as I'm suggesting from every lecture, I was suggesting every courses I am taking, right? So I'm suggesting fundamentals is very important, because once we get a clear idea over it, then everything going over advanced topics will be very much easier. So here we are taking the signals, which is a unit step signal. So unit step signal I have already teach you, but again I will teach this more on the types of signals I will take in the next few more classes, in next 2 classes. So this is signal, this is for x of t. So again another one signal, that is x of minus t. Okay, x of minus t means no, right? So there's a exact flip version. Okay, so the thing is that, so this is x of t. So this is x of t, this is x minus t, just a flip version. So this is t, so this is t, so this is 1, so this is also 1. So now what we are going to do is that we have to add both the signals. So y of t, which is equal to x of t plus x of minus t. Okay, so if we add the both the signal, so what will be the resultant signal is that, so here if you see, this is value, so here the value is 1, here the value is 0. Now what will happen over the interval is minus infinity to 0. So over this interval the graph has the same value. So this is what the thing we have to do. So both the signal are having the value, so the resultant value is just addition of 2. So if that addition of 2 is 0 plus 1 is 1. So here from minus infinity to 1, minus infinity to 0, the graph will have the value 1. Okay, so that is what, guys, so it will be 1. Okay, so from minus infinity to 0. So after that, let me write the axis. Okay, this is a timestamp axis. So after that, here also same. So here if you see, here the value is 1, here the value is 0. So if we add both the thing, this also from 0 to infinity, this will be same. So if we add the thing, this will also be 1. Okay, so here if you see, the signal that we are consider will be 1 for entire duration from minus infinity to infinity. So here if you see, the 0 to infinity is another interval. So if we add this interval, 0 plus 1 is 1. So that is how we are converting from one point to another point. Okay, so this is how the signal transition will happen. So this is how the normal addition of signal. So this will be y of t. Okay, I hope you guys are able to understand the thing, right? So here if you see, one more thing we have to consider here. You may get may not get it. So here if you see, here is an transition. So this is slope at a point. So here if you see, the change is 1, here if you see, the change is minus 1. So addition at a point means this both need to be added. So this is 1, this is minus 1, so this means this value will be need to be considered 0, right? So that thing, that's why I have given a bubble here, means at this 0 the value is undefined, because in unit step we may not know what the exact value. Some guys will say this is a 0.5, this is 0.5, even that is there, this value at to 0 this is considered to be 0. So that's why I have given a big bubble here, so that we have some undefined value, or the value is not defined properly in this graph. So that's why this point. So here there is a two thing, one is a addition at the interval, but this is addition at a point. So in addition at the point, so plus 1 minus 1, this need to be considered, and this point is considered to be 0 here. Okay, so please make a note of it, it's very important thing, guys. So next example what we are going to add is that I will be giving you, so you guys can pause the video and try to answer this one, so that you guys will have some idea over the solving question. I'm going to give some difficult problem. Okay, how we can solve the thing is, so this is the signal 1, so this is signal 2. Okay, so how we can take it is that let me draw the signal. So this is 1, so this is 1, so this is, let me draw signal 2 also. So here if you see, it is dipping to downwards. The signal maybe seems to be complex, but it is very easy, guys, so don't worry, I will solve, don't worry. So you guys try, I will also solve. So this is 1, so this is 1, this is 2, so this value is at 0. So this is x1 of t, this is x2 of t, so this is summation t, so the time axis is t. Okay, so the values are, this is at 2, then this value is at 1, so this value is at 1. Okay, here if you see, this is 1, this value is 1, this is 2. Okay, so this will be very simple. So you guys have to find out the resultant signal. So that is what the question, that is what the thing you have to do it. It will be very easy, guys, so please solve it. So please pause the video and try to answer it. Before that I will give you one clue. So here the value which is equal to 0, so our slope, even slope, is equal to 0. Here there is a net transition from 1. So here if you see, the slope is 1. So here if you see, the slope is minus 1. So here the net transition is minus 1. Then again the slope is going to 0. So here if you see, the slope is 1, here also 0. So here if you see, the net transition is 1, here the slope is 0, and here the net transition is minus 2. Then again the slope is going to 0. So I have tracked the signal. This is how we have to track the signal. So at every point of change we have to track the signal like this way. So I have written the slope and value, everything. So now what you have to do is that you have to consider each interval. So please name the intervals like minus 1, so 0, 1 and 2. Now what you have to do is that just you going to track the signal and add all the value. That is what. So please pause the video and try to answer it. I will solve the question now. Okay, I hope plenty of guys were able to solve this one. So let me draw the signal. So here if you see in negative axis there is no signal, means the exact, the what will be the negative portion, that will replicate here. So that I am doing here. So this will come as it is. So I am writing this is for 1 and then tracing to 2. So there will be no change in this one. So this will be as it is. So this will be 1 and this will be 2. So there is no change. So this is as it is 0. So net transition is 1. The slope is 1 here. Okay. So everything is 0, 1 here. Okay. So now we are having the two signals here. So here if you see, the slope is minus 1. Here if you see, the slope is positive. Means what is happened? The slope is 0 here. Okay. So the second rule what I said is that, second rule is that hold the previous position. So now the previous position is here. So we have to hold here, and the slope is 0. The slope is 0 means what? It will be straight up to at the interval 1. The graph value will go as it is. So this is the slope is equal to 0. Okay, because the slope, net change of slope is 0. So that's why here given the slope is 0, because 1 plus minus 1 is 0. Okay. So now if you see, this is minus 1, this is plus 1. This is a change at point. So this point, the value will be going to 0. So that's why I'm giving a bubble here, because this is not determinant, because plus 1 minus 1, the value, the net change is 0. So that's why I given a bubble here, but the previous position is holded here, that is 2. Okay. Now here after that there is a first signal have no signal, so this will be the exact replica. So it will come as it is. So we have to extend this as it is. So 1 to 2, the value will come as it is. So 1 to 2, the value will come as it is, and after that it will be going down. Okay. So this is how, guys. So I hope plenty of guys have a good idea. If you guys haven't able to solve this while I was giving, so this is how the signal transition will look like. So just we have to track all the parts in the signal, and then we have to add it. Very easy, normal mathematics, right? So entire signals and system is mathematics only. So this will be very easy for you guys to track it. So I hope this is understood for you guys. If you guys have any doubt, please post in the comment section. I will be there to help you guys. So please post all your doubts, like, share, and subscribe the channel. Stay tuned for more videos like this. Thank you guys. Next class we see odd and even signals.